All right, let's do this today. We're on 9.3.1, and what is our EQ? It is, what if the inequality has two variables? Uh-oh. I know that's probably terrible. What if the inequality has two variables? What do we do? Well, we're going to graph two variable equations. In other words, linear equations. That's what we're doing right here. So let's just get used to graphing, right? Okay, we're going to do it with inequalities, but what happens graphing two variable equations? They should say inequalities. Inequalities. We've been doing equations. We need to do inequalities. All right. But first, we are going to graph the equation y equals negative 2x plus 3. Don't forget, this is my b, or start value. This is my, oh, I got to include that. This is my m, or growth factor, right? So if it starts at 3, boom, go up to 3, and my growth factor is negative 2, so that means go down 2 over 1. I'm going to do it once more, down 2 over 1. Let's get my handy-dandy triangle ruler. Pow! And let's just graph it. And what is that? That's y equals negative 2x plus 3. Boom. All right, we're good. So that's just a quick refresher on graphing, but let us define some things. You may know this, you may not. Do you remember how when we did our other graphing, we had the closed dot is for less than or equal to or greater than or equal to, and the open dot is for less than or greater than, right? We have to do something similar for graphing lines. So a solid line means less than or equal to or greater than or equal to. And a dashed or dotted line, depending on how you do it, means less than or greater than, okay? Also, when we're showing an area, now normally on the little number lines, we just do a little arrow left or an arrow right. Well, now we're talking about two dimensions, so we're going to actually have to shade an area. And to know which area to shade for greater than or equal to, put your pencil, or I should say your pen or pencil, right? See how I did that? On the line and shade up. Come on, pen, don't fail me now. For less than or equal to, put your pen or pencil on the line and shade down. Okay? Some of this I'm just defining. You'll see what it means when we go into practice, so let's do some practice. Let's do this first one here and try to keep everything at least sort of visible. Okay, notice this is almost identical to what we had up here, right? The only difference is now I'm saying less than or equal to. Treat it the same, though. I'm going to graph the same way. Start value of 3, slope of negative 2, so I'm going to go down 2 over 1, down 2 over 1. Remember, negative goes down, positive goes up. That's the difference. And let's identify this. Less than or equal to means solid line. So I'm just going to write solid. That way I know. Here's where it gets really different, though. It says less than or equal to. What do we do for less than or equal to? Put your pencil on the line, shade down. So that means we're going to shade down here. And for our graphing purposes, just kind of give it a good shade, because potentially this graph goes on forever that way. And what that tells us is any y within the shaded area, so underneath this line, satisfies the inequality of being less than or equal to 2x plus 3. So it can be any point below or even on the line. All right, let's do the next one. Oh, it looks similar, very similar, except for this one's greater than. And what do we do for greater than? Dashed or dotted line. So again, still mark our points. We start at 3, down 2 over 1, down 2 over 1. But don't forget, I got to do a dashed or dotted. I usually do a dashed. And then it said greater than. Greater than, remember up here says put your pencil on the line and shade up. So on the line and shade up, which means up here. Definitely shade in all that box. And what this tells me is any y inside the shaded area, but not on the line. Line not included, but inside the shaded area satisfies this inequality and makes it true. Now let's do a couple of extras. I'm going to go ahead and pause it, give you a chance. So we have a start value of 1, a slope of 2. Remember, positive goes up instead of down. Let's go ahead and do this. Go ahead and try graphing it. Identify what kind of a line, right? It's greater than or equal to. And then figure out what direction I need to shade it. Follow the directions. Where does greater than go? I'm about to unpause this, so if you need extra time, go ahead and pause it now. Boom, look at that. Start value of 1. Slope says up 2 over 1, up 2 over 1. Did that a couple times. It's a solid line because it's or equal to, which means any y in the shaded area, oh, and it was greater than, so I put my pencil on the line and shaded up, and that is greater than or equal to, so any y value in here or on the line makes the statement true. Real quick, what do I mean by makes the statement true? I just want to show you that. That means let's pick a y, so I'm going to pick 4 for my y. And what's the x value there? So that'd be 4, 0. Let's see what the point 40 does. So if I'm going to look at the point 40, which is a point inside this, is it going to make me a true statement? Well, let's find out. Or excuse me, that's 0.04. What am I thinking? Maybe some of you caught it while watching this. So I'm going to have 4 is greater than or equal to 2 times 0 plus 1. That goes to 0. I end up with 4 is greater than or equal to 1. Yep, that's true. So any point inside of here is going to make that true. All right. Let's go ahead and do our last one here. Again, I'm going to pause it. Go ahead, take a minute, graph it. Y is less than x minus 1. Make sure you identify what kind of a line are you going to use. What number's in front of the x, even though we don't see it? You draw your lines all the way through, put arrows on the end. Where does it tell me to shade? And I'm about to unpause it, so if you need more time, go ahead, take it. And here we go. Boom. And again, let's test the truth of this. Remember, it can't be on the line, but I'm going to pick this point right here, which is 5, 2. So let's look at the point 5, 2. Just to test to see what happens. I'm going to have 2 is greater than, or excuse me, less than. It's less than. See, that is less than. My bad. Less than 5 minus 1. So 2 is less than 4. Yep, that's true. Boom. See, it works. All right, this is your introduction to graphing two variable inequalities. So, got homework on back. Go ahead and check it out. I gave you some graphs, some stuff to do. Read the directions. Stuff's below. Peace out.